Hello and welcome to my YouTube channel. Today we shall be looking at integrals of the form u prime of x over u of x dx. You shall recall that if y is equal to ln x, the natural log of x, then if we differentiate dy over dx of the function ln x, we get 1 over x. Now, since integration is the reverse of differentiation, we would expect that if we integrate this function with respect to x, we get what? Ln x. That is to say that the integral of 1 over x with respect to x is nothing but what? Ln x. But then, let us take a second look at this integral. We observe that 1 over x, 1 here is the numerator and x is the denominator of the fraction 1 over x. Let me write it out here, 1 over x. We observe that if we differentiate the denominator, what do we get? The numerator. Because if you differentiate x, you get what? 1. So the integral we're dealing with here are integrals of this form, where the numerator is the derivative of the denominator. And once we encounter such a function under our sign of integration, we simply write the answer as what? The ln or natural log of the denominator, which is what? Ln x in this case. So the integral of 1 over x dx is simply what? Ln x in absolute values. We shall take other examples now to illustrate this process even more. Take for instance, we are asked to integrate 4 over x dx. So what do? 4 is a constant, so I can take 4 out of my integral sign and I have 4 integral of what? 1 over what? X dx. What do I observe here? I see clearly that if I differentiate x, the denominator, I get 1, and 1 is the numerator. So 1, the numerator, is the derivative of the denominator. Once I'm able to spot this, I'll simply write this as what? The integral of 1 over x with respect to x is simply what? Ln absolute value of x. Since there's a 4 out here, that becomes 4 ln x plus c, where c is a constant of what? Integration. Now we're asked to integrate 2x squared plus 4 divided by x cubed plus 4x minus 6 with respect to x. Now let us see if this trick will work here. The denominator is x cubed plus 4x minus 6. If we differentiate this denominator, what do we get? Differentiate this, you get 3x squared plus 4. So we look at the numerator. What we have there, we have 3x squared plus 4. So indeed, the numerator of this function is the derivative of the denominator. So what do we write? The derivative of this, the integral rather, of this function simply is what? The ln of the denominator, which is what? Ln x cubed plus 4x minus 6, then plus what? C, your constant of integration. The next example, integrate 1 over 4x plus 6 with respect to x. Let us check again if we can apply this technique we are learning just now. If we differentiate the denominator, which is 4x plus 6, what do we get? We get 4. And the numerator is 1, not 4. So it appears as though this technique cannot be applied, which is true. However, it is possible to rearrange this equation in such a way that this technique remains possible, as follows. What we need in the numerator is 4 and not 1. So if I write 4 over 4 outside the integral and now write integral of 1 over 4x plus 6 with respect to x, I have not changed the integral because 4 over 4 is 1. And this simply means multiplying the integral by 1, which does not change the integral. So 4 over 4 is just 1. Why have I done this? It shall be clear in a second. Since I need 4 here, and I'll bring this 4 inside and I have 1 over 4 left out, integral of this 4 goes in, becomes 4 over 4x plus 6 with respect to x rather. And I'll look at the integral one more time and check. If I differentiate 4x plus 6, I get 4. So the form which I wanted is achieved. This now becomes 1 over 4 is outside already. Since the differentiation of the denominator gives me the numerator, I can now write the ln of 4x plus 6 plus c, my constant of integration. Next, we want to integrate tan x with respect to x. Now by observation, the function here is tan x and it is not a fraction. However, we know that tan x is a ratio of sin x and over what? Cos x. So we can write this as the integral of sin x over cos x with respect to x. We now check if this method can be applied. If we differentiate cos x, what do we get? We get minus sin x. And what we have here as a numerator is sin x. So there's an extra term, which is what? The minus. So like we did in the previous example, we shall now introduce minus over minus outside the integral. That becomes minus over minus, which is minus 1 over minus 1, integral of sin x over cos x dx. Since I want a minus sign here, I can now push this other minus inside and I'll get the following. We get integral, this becomes minus sin x in over cos x with respect to x. This minus here is now in. What is left here is just one minus. So what is left there is minus integral minus sin x over cos x. So we check again. If I differentiate cos x, I get minus sin x. And the form which we want is now achieved. So this becomes minus the ln of the denominator, which is what? Cos x, plus what? C, the constant of integration. Exercise. See if you can apply the technique we have just learned, to perform this integration. And then leave your answers in the comment section below. Please do not forget to subscribe to this YouTube channel. Thank you and bye-bye.